more examples of being able to evaluate trigonometric integrals that involve secant and tangent. So now we have a tangent to the 10th, secant to the 4th of x dx. As if anybody would ever want to integrate that or use that to model anything, but let's just say for some reason it does. To be able to evaluate this function or this integral, let's employ the same strategy that we did with the sine and cosine. And if we have two bigger powers of tangent and secant, let's pick on the smaller power. Now we know that secant squares are nice, but also tangent secants are nice, but I'm going to go ahead and split off a tangent or secant square, excuse me, from this integral. So we're going to have still tangent to the 10 of x, right? Sec square of x, and another sec square of x dx. Now we can use the Pythagorean identity on one of those two secant squares, and we know that the derivative of tangent is secant square. All right, so we go back up, we look at our identity, and we know that tangent is secant square minus 1. All right, so this is now going to be the integral of tangent to the 10th of x, and then instead of secant square, it's going to be tangent x. I'm sorry, 1 plus tangent x. Sorry, I think I used the wrong one. Just want to make sure. So apologies. Make sure that you use this 1 plus tangent square x to go from your secant square. It's going to be 1 plus tangent square. And then finally, we still have the secant square of x dx. All right, now we can go ahead and employ the u substitution. So let's let u equal the tangent of x. Du is going to be equal to secant square of x dx, precisely what we need. Now we can substitute, and it's going to be the integral of u to the 10th, 1 plus u squared, okay? So just substituting there. And then instead of secant square x dx, that's going to be du. Distributing the u to the 10th. So now it's easy at this point. So u to the 10th, u to the 12th, du. And now if we evaluate, that becomes u to the 11th over 11, u to the 13th over 13, plus the constant of integration c. Recalling that u was tangent, this just becomes tangent 11th over 11th x. So tan 11x over 11 plus tan 13th of x over 13 plus our constant of integration c. All right, so hopefully that wasn't too bad. All right, just making sure though that we're good with our identities, and it might take some trial and error when you're doing this. Another example, tangent to the 5th of x. All right, so this one's a little bit more difficult because we don't have a secant, nor do we have a secant tangent. So we can't break off a sec square, we can't break off a secant tangent. And so what we might want to do is start by breaking off a tangent to get the tangent to the 4th. But realistically, to write this as tangent to the 4th of x, tan of x, dx, that's not going to help us because we don't have anything like a derivative of secant or a derivative of a tangent that's going to give us just a singular tangent. All right, so we need a secant in there as well. So here's another thought. Let's rewrite this as tangent square tangent cubed. Okay, so this is going to be tangent cube x tangent square x dx. And the reason we do that is because we know that there's a Pythagorean identity for the tangent square. All right, so remember we have our tan square is going to be sec square x minus 1. All right, so going back down here, we can now rewrite this as the integral of tan cube x, and then we said sec square x minus 1, just to make sure I'm writing it correctly. All right, so this is going to be our sec square x minus 1 dx. Okay, so some good news. If we use the u substitution for tangent, the derivative we know is secant square of x dx. but that doesn't give us secant square x minus 1. And so we can't immediately go to the u substitution yet, unfortunately. All right, but what we could do is break this up into two separate integrals. All right, so this is a little bit sneaky, but it's okay, we got it. So we're going to have integral tan cube x sec square x dx minus integral tan cube x dx. Now this one's ready for integration. All right, so we're just going to hold on to that for right now because we could do a u sub. Tan cube is not ready for integration. The good news is, though, we can just go ahead and immediately do the exact same thing as we just did and rewrite this as the opposite of the integral of tan x tan square x dx. Right? Horrible looking tangent, sorry. This one might not be any better, but it looks a little bit better. We can use the Pythagorean identity again, sec square x minus 1 for your tan square. Dx. And now we're going to drop down the other integral. So we have our tan cube x sec square x dx minus all of that stuff. Okay. Now we're going to break this up one more time and distribute. And now we're going to have three integrals. All right. And so our next line, okay, we're almost to the point where we get the u substitution. We're going to have the tangent cube x sec square x dx minus, we have our integral of tan x sec square x dx. Finally, minus times minus is going to become a positive tangent x dx. All right, so apparently I can't write the word tangent in the screen. You just write on the teacher evaluation at the end. All right, good news is u substitution for both of these. All right, so we're going to let u be equal to tangent of x, and our derivative du is going to be secant square of x dx. Good. So that's what it's going to make these go away and those go away and write them in terms of u. So we are now going to have integral of u cubed du minus integral of u du. Okay, so we're just substituting u for tangent and then du for sec square x dx. And then we still have this tangent of x dx integral. That one's basic. And so now we can go ahead and finally evaluate all of these. Okay, so antiderivative of u cubed, u to the fourth over 4. Antiderivative of u squared, or u is going to be u squared over 2. And then the antiderivative of tangent, that's one where you're going to have to look on your formula card, okay, or maybe at the very beginning. All right, and this is actually going to be the natural log of the secant of x plus c. All right, and just to show you which formula card I'm referring to, what you guys can do is you can go in the Blackboard. So let me show you that really quickly, that if you were to go in the Blackboard, and if you were to go under exam reviews and exam reflections, right, there's a reference card for the examinations. You can click right here on that. All right, and if you scroll down just a little bit, we can get to our integrals, okay? And we can see that the integral of tangent somewhere on here is the natural log of the secant function, okay? So this might be a helpful sort of entity to have, especially for these types that, you know, you've done them before, but you might not just remember them off the top of your head, okay? Finally, we need to back substitute, all right? And to finish this off, remember that u is equal to the tangent, so we are going to end up with tangent fourth of x divided by 4 minus tangent square of x divided by 2, and make this look like a real tangent, not t and 2 mystery characters, plus the natural log of the absolute value of secant of x plus c. All right, that's our answer. If you want to find the derivative of that and then whack it with a whole bunch of trigonometric identities, that'll get you back to the original problem. Okay. All right. So in our last video, after this one, we're going to have a couple more examples of being able to evaluate these types of functions involving secant and tangent.